Okay, so today I want to talk about section 12.6, the binomial theorem. By the way, I have a handout. It's also in the class notes, you know, with chapter 12 notes. It's embedded in there about binomial expansion using Pascal's triangle, and then the binomial theorem, which we're going to talk about in 12.5. This is also posted on D2L under content, under handouts, and it's also in the notes. Okay, make sure you go through that. So how to expand a binomial a plus b to the n, where n is a counting number, okay, or even a whole number. So if you do a plus b to the 0, this is 1. If you do a plus b to the first power, it's a plus b, 1a plus 1b. A plus b squared, it's a plus b times a plus b, which is a squared plus 2ab plus b squared, 1, 2, 1. If you do a plus b cubed, it's a cubed plus 3a squared b plus 3ab squared plus b cubed, 1, 3, 3, 1. If you do a plus b to the 4, it's a4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b4. One more. I mean, I'll show you. This is not hard. a5 plus 5a4b plus 10a cubed b squared plus 10a squared cubed plus 5ab4 plus 1b5. So it's 1, 5, 10, 10, 5, 1. Okay, let's look at some observation here. Actually, here, let me go over this. There are, so what I was going over, there are one more term than the power of the exponent. That is, there are n plus 1 terms in the expansion of n plus a plus b to the n. 0, 1, 1, 2. The power is 2, you got 3 terms. If the power is 3, you got 4 terms. 4, you get 5. 5, you get 6. In each term, the sum of the exponents is n, the power to which the binomial is raised. In each term, 1, 1, 1, 2, 2. 1 plus 1 is 2, 2. 3, 2 plus 1 is 3. 1 plus 2 is 3, 3. 4, 3 plus 1, 2 plus 2, 1 plus 3, 4, and so on. The first term is always a n b0. Last term is always a0 bn. So a n b0, a0 b1, a2 b0, a0 b2, a cube b0, a0 b cube, and so on. Exponents of the first term decrease by 1, while exponent of the second term increase by 1. You can see we start with a2 b0, then this decreases at the same time this increases. 1, 1, this goes to 0, this goes to 2. a cube b0, a2 b1, a1 b2, a0 b cube. Like if you go to a plus b6 to get those, you always start with a6 b0, and then a5 b1, and then a4 b2, a cube. You see how these terms come out? a2 b4, a1 b5, and then a0 b6, and you get 7 terms. One more than this. 1, 2, 3, 4, 5, 6, 7. Very interesting. The coefficients start at 1 and increase and then decrease in a symmetrical manner. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1. No, this we don't have the coefficients yet. To find the expansion of a plus b 8, we complete 2 more rows because we already have 5, so we can do a couple more rows, and that's going to give you the expansion of a plus b to a. The only disadvantage that the Pascal's triangle has is it takes a lot of, here's what I have. It takes a lot of space. Like if you want to do a plus b to the 8, you know, you have to do all this work. And you can see how to get the triangle, the Pascal triangle, a plus b to 0, so you the coefficients of 1, that's how you get the coefficients. Look, for a plus b to 0, it's 1. A plus b to the 1, it's 1, 1. You make a triangle, 1's at the end always. A triangle, 1's at the end, and then you add the numbers to put that in the middle. 1 plus 1 is 2. So for a plus b, 2 is 1, 2, 1. 1, 2, 1. For a plus b cubed, you bring the 1's down, and then you add 1 plus 2, you put it in the middle. 2 plus 1, you put it in the middle. And then 1, 1 for a plus b to the 4. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And so on. Okay, that's how you get the coefficients. So, number 8, page 886. Use Pascal's triangle to expand x minus y to the 5th. So the first thing we want to do is write it as a plus, a plus b. So x plus negative y to the 5th. Okay, we're going to get the terms and then put the coefficients. So you're going to get x, this is to the highest power, negative y to the 0 power. And then that decreases by 1, this increases by 1. Decreases by 1, increases by 1. Decreases by 1, the second increases by 1. And then x1, negative y to the 4. And then x0, negative y to the 5th. And then the coefficients, you do the triangle. If you don't, you're not going to have it, so you have to make it up. So for n equals 0, you get 1. For n equals 1, 1, 1. N equals 2, 1. 1 plus 1 is 2, 1. N equals 3, 1. 1 plus 2 is 3. 2 plus 1 is 3, 1. N equals 4, 1, 4, 6, 4, 1. We need 5, so 1, 4 plus 1 is 5, that's 10, that's another 10, that's 5, and always 1 at the end. So we put 1, 5, 10, 10, 5, and then 1. And then we gotta clean it up. So this would be x to the 5, that's a 1. 5x4 times negative y is negative 5x4y. This is positive y squared times 10x cubed. So 10x cubed y squared, negative y cubed times 10 x squared y cubed. 5x, that's positive y to the 4, so 5x y to the 4, and then that's a 1 times negative y to the 5, so negative y, 1, 2, 3, 4, 5, 6. Okay, so this requires a lot of space, a lot of work to get the coefficients. The binomial theorem, which is right here, it doesn't require all the space. It's more efficient basically, and it does the same thing. The binomial theorem for expanding a plus b to the n. So we know that how the terms are going to play out. The coefficients is what we're looking for. Instead of doing the triangle, the binomial coefficients will give us all coefficients of binomial expansion using a combination of n, choose r of m at a time, or we can write it like this, n choose r. What this is, it's n factorial over r factorial n minus r factorial, where r is equal to n. Now if you don't know what factorial is, when we say 5 factorial, this is exclamation mark, is called factorial. What it means It means you start at that number and then you times by the next one below it, and then the next one below it, and then the next one until you get to 1. So you can see that 5 factorial is 20. No, 5 times 4 is 20, 60, 120, sorry. And then factorial, again, you start at 4, the next one below that, the next one below that, 24. By default, don't ask me why, 0 factorial is 1. 1 factorial is obviously 1 because you start at 1 and then you have to end at 1. 2 factorial is 2 because it's 2 times 1. 3 factorial is 6, 3 times 2 times 1. And your calculator actually can check that for you. So let's say you want to do 6 factorial, so you go to 6 and then math, and then you're going to go to probability right there, and you can see number 4 is the factorial, and it's going to do 6 times 5 times 4 times 3 times 2 times, it's 720. Okay, so you have a calculator to do your work. Now, so when we have say number 18, page 886, what is 8 choose 3? Remember the other notation, the calculator notation would be this. This is 8 factorial over 3 factorial, and then 8 minus 3 is 5 factorial. So you can do 8 math, and then you do number 4 divided by, because you need to times these between parentheses, 3 factorial, and then 5 factorial. And then by parentheses, and that's 56. Look. This is 56. Remember, 8 factorial, if you want to do it by hand, it's 8 times 7 times 6 times 5 factorial. Why 5 factorial? Because 5 times 4 times 3 times 2 times... And I want to stop so I can cancel these out. And 3 factorial is 3 times 2 times 1, which is 6. That cancels out. 8 times 7 is 56. Also, you can do this and get 56 using your calculator. Look. So do C8. So if you have 8 units and you want to choose, you want to see all the combinations of 3 at a time. You're going to do 8 first, and then go to math. You're going to go to probability, and you can see it's number 3 and C choose. So put 3, and then you see how it overtakes, the 8 overtakes the n, and then 3, and there we go, 50. Okay. So now the formula for the binomial theorem, so to expand a plus b to the n, it's going to be, remember you're going to do a n b0 plus a n minus 1, this decreases by 1, plus a n minus 2 b square plus a n minus 3 b cubed plus the last one would be a0 bn. Now the coefficients are the ones we're going to talk about. It's going to be n choose 0, so n choose 0, and then it's always n here, n choose 1, so it's always n on top, or n here, and then these values are the exponent of the second term. Okay, n choose 2, n choose 3, and then n choose n, which is 1 if you do the math. Okay, which means what's important is that which means the coefficient of an minus r is n. Remember, that's always n choose r. Keep that in mind. Okay, so n choose r. And also look, b to the 0 is in the first term, b to the 1 is in the second term, so the exponent of b is 1 less than its location. This is in the second term, its exponent is 1. This is the third term, the exponent of b is 2. This is the fourth term, the exponent is 3. Keep that in mind. So if they say find the fifth term in expanding 2x plus 5y to the 10th. You can do the whole thing to get the fifth term, or you can say in the fifth term b, which is 5y. Remember, in the first term this is 0 power. In the second term it's going to be first power. In the third it's second, in the fourth it's third, in the fifth it's going to be 4. So this should be 4, which means 2x has to be, because they have to add up to 10, this should be 2x. And then the coefficient is going to be n, which is 10, choose 4. Okay, so choose 4, which is 10 factorial over 4 factorial, 6 factorial, that's 2 to the 6, which is 64, x to the 6, 5 to the 4 is 625, y to the 4, so it would be 8,400,000, x to the 6, y to the 4. Now let me tell you one thing about the coefficients. Remember, there's two ways. There's Pascal's and there's the binomial theorem. There's also the Dakka's way, my way. Look. See how you have, okay, this is always going to be a 1, this is always be a 1. That's b to the 0. 1n, 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 1, this should be 6, and so on. Okay, we'll finish that, but let's look at this one first. If you don't have the 5, how do you get, so you start with 1, this is what you do to get the next one. 1 times 5 is 5, divided by 1 more than this. 1 more than this. 1 times 5 is 5, divided by 1 is 5. 5 times 4 is 20, divided by 2, 1 more than this. 5 times 4 is 20, divided by 2 is 10. 10 times 3 is 30, divided by 3 is 10. 10 times 2 is 20, divided by 4 is 5. Now it's symmetrical. 1, 5, 10, 10, 5, next one is, we know it's 1. Look, let's get these now. 1, this is always a 1. 1 times 6 is 6, divided by 1 is 6. 6 times 5 is 30, divided by 2 is 15. 15 times 4 is 60, divided by 3 is 20. Isn't that neat? You don't need any binomial or Pascal's triangle. 20 times 3 is 60, divided by 4 is 15. 15 times 2 is 30, divided by 5 is 6. We know it's going to be 6. It's symmetrical, and that's always a 1. Isn't that neat? It will always work. And you can use it if you don't want to use Pascal's or the binomial theorem. Okay. So I want to do one more before I let you go on this section. So expand a minus 3b to the 5th using, on the test, I'm not going to, you can do anything you want with the coefficients. You don't have to use binomial or Pascal or my way. So a minus 3b to the 5th, we'll have to write it first as a plus 3b, negative 3b to the 5th. So the terms, I'll put the coefficients later. So a to the 5th, negative 3b to the 0. A to the 4, negative 3b to the 1, a cubed, negative 3b squared, a2, negative 2b cubed, a1, negative 2b 4, and then a0, negative 2b 5. I should have 6 terms with 3, 4, 5, 6. So that's always a 1, or 5 choose 0. This would be 5 choose 1. This would be 5 choose 2, 5 choose 3, 5 choose 4, and that's a 1, or 5 choose 5. Okay, and or you can do what I did. 1 times 5 divided by 1 is 5. That's a 5. 5 times 4 is 20, divided by 2 is 10, and so on. 5 choose 2 is 10. So So this would be a5 plus 5a4 times negative 3b plus 10 a cubed times 9b squared, and 30 over 3 is 10, that's also a 10, a squared times negative 8b cubed plus 5 10, okay. 5 negative 2 to the 4 is 16. B to the 4. A to 0 is 1 minus 32 B to the 5th. Oh, that should be 3. Why do I have a 2 here? My bad. A 3, and I wonder why these numbers are not working out. Let's fix this. So negative 27. Okay, and this would be A, that's 81 times 5 is 405 B to the 4, and that's negative 243 B to the 5th. Okay, I want to redo this because I think I make it a little harder than it is. Okay, so it's 5 to 0, A5, negative B to the 0. 5 choose 1, A4, negative 3B to the 1. 5 choose 2, A cubed, negative 3B squared. 5 choose 3, A4, A2, negative 3B cubed. 5 choose 4, A1, negative 3B 4. 5 choose 5, A0, negative 3B to the 5. So that's a 1. That's a 1, so that's A5 plus 5 choose 1 is 5 times negative 3 is negative 15 A4B. 5 choose 2, that's a 10 times 9 is 90 A cubed B squared. That's another 10. 5 choose 3, and that's negative 27, so negative 270 A squared B cubed. That's a 5. And then 81, 405 A B to the 4, that's a 1, and that's negative 243 B to the 5th. That's better. And you can see the coefficients, and that's it for 12.6. I still want to do a little bit of 12.5, which is optional. Just want to mention the mathematical induction in the next one for maybe 5-10 minutes max.